So, how did we get here? From a computer designed that, get this, was never even built, all the way to this intelligent network that's basically woven into the fabric of our lives. It's an absolutely incredible journey. And today, we're going to chart that whole path, from these giant mechanical dreams to the invisible web that's all around us. Just let that sink in for a second. We're talking 1949, and the idea that a machine could help with your taxes, that was pure fantasy, just total speculation. This quote is just perfect because it shows you how completely unimaginable our world would have been back then. It really sets the stage for a revolution that honestly nobody saw coming. Okay, so our story actually starts way before you might think, over a century before the first electronic computer was even a thing. See, the whole concept of a powerful all-purpose computer, it didn't start with electricity. Nope, it started with gears and levers and one heck of a brilliant mechanical vision. And here it is, the Analytical Engine. This was designed by the brilliant Charles Babbage, and you really have to think of it as the blueprint for everything that came after. Seriously, it had a mill for doing the math, that's basically what we'd call a CPU today, and it had a store to hold the numbers, which, you guessed it, is memory. It was a computer in every conceptual sense, long before we had the electronics to actually build one. I mean, just look at this design. It's kind of mind-blowing. All the core pieces of a modern computer, they're right there. You've got input using punched cards. You've got memory. You've got a processor that could do loops, and even conditional branching, which is just a fancy way of saying it could make simple decisions. And get this, it even had the world's first programmer, the amazing Ada Lovelace, who wrote the first real algorithm for it. The only thing it was missing? Yeah, the funding. It was never actually built. All right, now let's hit the fast forward button and jump ahead about 100 years to the 1940s. This is when Babbage's mechanical dream finally becomes a reality. But not with gears and levers. Oh no. This time it's with thousands and thousands of glowing vacuum tubes. This is the birth of the first electronic computers. And here it is, ENIAC. This beast was completed in 1945, and it was the world's very first programmable, electronic, general-purpose digital computer. I mean, the first one. When it was shown to the public, the press didn't even know what to call it. They landed on giant brain. And you know what? Given its ambition, they weren't too far off. And when we say giant, we really mean it. ENIAC weighed 30 tons. It filled an entire room. It had 18,000 vacuum tubes that were constantly burning out, so it was super unreliable. And to top it all off, it sucked down enough electricity to power a small town. This was computing on a truly colossal, almost absurd scale. So how did you program this thing? Well, it had absolutely nothing to do with typing on a keyboard. It was a massive physical effort of rewiring plug boards and flipping thousands of switches. It could take weeks just to set up one problem, like its super important job of calculating artillery tables during the war. And who were the masterminds behind this? A team of 6 brilliant women, true pioneers of programming, whose absolutely foundational work was sadly overlooked for decades. Okay, so after the age of these giant brains like ENIAC, the story of computing takes a sharp turn. It becomes a story of relentless shrinking. The next big breakthrough wasn't about making computers bigger. It was about making them smaller. And not just smaller, but faster, cheaper, and way more reliable. And wow, does this picture tell that story perfectly? This little thing is the Intel 4004 microprocessor from 1971. And it packed all the computing power of that massive 30-ton ENIAC onto a chip smaller than your fingernail. Think about that. The power of an entire room could now literally fit in the palm of your hand. So how did this incredible shrinking act even happen? Well, it was all thanks to a lightning-fast series of breakthroughs. First, those big, clunky vacuum tubes got replaced by tiny transistors. Then, engineers figured out how to cram thousands of those transistors onto something called an integrated circuit. And then, the final leap, the microprocessor, which put the entire computer, the brain, the memory, everything, onto one single chip. Each step was a massive jump, making computers exponentially more powerful and affordable. And that microprocessor? It didn't just make computers smaller, it made them personal. Because once you could put an entire computer on a tiny chip, the cost just plummeted. And that sparked a revolution. It took computing out of these massive corporate data centers and put it right on a desk, in our homes and offices. I mean, before the mid 70s, computers were things that only giant corporations or universities could afford. But then, these hobbyist kits started popping up, like the Altair 8800, and clubs like the legendary Homebrew Computer Club started forming. This created this whole new culture of enthusiasts, and yeah, that included people like Steve Wozniak and Bill Gates, who were all looking at this stuff and thinking, hey, what if everyone could have one of these? And then 1977 happened. That's when the revolution really caught fire with what we called the trinity of personal computers. You had the Apple II with its color graphics and expansion slots, which made it the perfect platform for the first spreadsheet, VisiCalc. That was a total game changer, a real killer app. Then there was the Commodore Pete, this tough all-in-one machine for business, and the TRS-80, which you could just walk into a Radio Shack and buy. Each one was different, but together, they basically invented the personal computer market as we know it.
All right, so that journey brings us right up to the present day and lets us peek into the future. Because the story isn't about a beige box on your desk anymore. Not at all. Today, computing is breaking free of the box, becoming this invisible, intelligent fabric that's just woven into everything we do. Right now, we're in what's called the fifth generation, and it's all about artificial intelligence. We're talking about computers that can understand us, that can learn, that can adapt. You know, things like Siri, Alexa, ChatGPT. And a huge part of what makes this possible is something called edge computing, which is all about taking that intelligence out of the cloud and putting it directly into the devices around us.
And this idea of edge computing is a really big deal. What it means is that the thinking happens right there on the device itself, on the edge of the network, instead of being sent off to some faraway server. Why does that matter? Well, it's what lets a self-driving car react instantly to something in the road, or a factory robot work without any delay. There's no waiting for instructions from the cloud. But if we look even further down the road, the next great revolution is already starting to take shape. This is the emerging sixth generation, and it's all about quantum computing. And it promises to completely redefine what's even possible using the truly weird and powerful rules of quantum mechanics. So what's the big difference? Well, a normal computer bit is simple. It's either a 0 or a 1. That's it. But a quantum bit, or qubit, is where things get weird. Thanks to a principle called superposition, it can be a 0, a 1, or both at the same time. And that ability to hold multiple values at once means it can explore tons of possibilities simultaneously. This could let us solve problems that are just flat out impossible for even our best supercomputers today, especially in areas like medicine and science. So when you step back, the journey is just staggering. We went from one single giant room-sized brain to having intelligence packed into pretty much every device we own. The first computers were tools that we had to command. This next generation, they're more like partners that can learn and predict, which leaves us with one final big question to think about. What happens when this journey is finally complete and every single object around us has a brain of its own?